Our continuous use of our chemistry education. What are we going to be looking at this afternoon? We are going to be looking at one of the gas law which you have. The gas law we have the Boyle's law, we have the Charles law, general gas equation, ideal gas equation, Graham's law of diffusion, and the rest. But which one are we going to be looking at this afternoon? We are going to be looking at Boyle's law. Boyle's law. So this Boyle's law, in 1662, there is a man they call Robert Boyle. He did an experiment. He now came about this law, which now said and we call Boyle's law in 1662. So what does the law say? The law says that the volume of a given mass of gas is inversely proportional to the pressure, provided the temperature remains constant. Like in gas law tends to look at the relation between volume, temperature, and pressure. But in this Boyle's law focuses on volume and pressure. So it said that the volume of a given mass of gas is inversely proportional to the pressure. So that is provided the temperature is kept constant. So it focuses on volume and pressure. Meaning that as the volume of the gas increases, the pressure will decrease. They are inversely proportional. Having said that, what is the mathematical relationship? Now, I should have told you about the line of dating. Our line of dating, like the idea is that you will find Boyle's law, which you have done. You will look at write the mathematical expression of the Boyle's law. What about the graphical representation of the Boyle's law? You will also write it. And we look at calculation based on Boyle's law. These are four line objectives. We have stated the Boyle's law. We say that the volume of a given mass of gas is inversely proportional to the pressure. As the volume increases, pressure will decrease. Now let us look at the second line of objective, which is called mathematical expression. From the mathematical expression, we are going to have something like that is V is inversely proportional to the what? To the pressure. Your V is the volume, our P is the pressure, where our temperature is kept constant. So we focus on volume and pressure. So if you want to introduce constant term, we are going to have V is equal to what? K over P. So when we cross multiply, we are going to have PV is equal to K. So you can see that the product of the pressure and volume is equal to constant. So this is a mathematical expression of the Boyle's law. So if you want to finalize the whole thing, we are going to have P1 V1 is equal to what? P2 V2. What is P1? What is V1? What is P2? What is V2? P1 is what? Initial pressure. We call it initial pressure. We call it initial pressure. Okay? Alright? And then V1 is also initial volume. Initial volume. What about P2? P2 is what? Final pressure. Final pressure. What about V2? V2 is what? Final volume. Final volume. That's called V2. So anything 1 is initial. Anything 2 is what? Final. So this is the mathematical expression of the Boyle's law. P1 V1 is equal to what? P2 V2. Okay. So having said that, what about the graphical representation? Graphical representation. So which are four lines of them. So if you want to represent it graphically, so graphical representation, you can do it like this. Graphical representation. That means we can represent it in graph. So you are going to have something like this. You can have something like this. You can have something like that. So vertically, let's say this is volume. V is volume. Vertical axis. Okay. And what about the horizontal axis? Let's say you are having what? Pressure 1 over P. 1 over P. If we have 1 over P, so this one is going to give us what? Straight line. Why do we have straight line? Because P against 1 over P obey Boyle's law. So that is going to be what? Directly. It's going to be what? Straight. But if you have something like this, you have an expression like this. V against P like this, we are going to have a curve. Because this one does not obey Boyle's law. But unlike the other one, P against 1 over P the straight line. But if V against V is going to give us up, because this one does not obey Boyle's law. Now, having said that, let us now look at our last line of the which is called calculation based on Boyle's law. Calculation based on Boyle's law. Now, here we have a question. The question is that 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750. So we are being told that 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. Find the volume now if the pressure is reduced to 750. So automatically what we are going to get here is that our volume is going to increase. In fact, it should be more than this, because when you reduce the pressure, volume will do what? Increase. So how do we go about it? Solution, expression. So let us go identify our initial volume, initial pressure, final volume, final pressure. So we are going to have our V1. The first mentioned volume is going to be our V1, 375 centimeter cube. What about our P1? The first mentioned pressure here, 770 millimeter mercury. Okay. What about our V2? Our V2 is unknown. Let's call it what? X is unknown. Okay. And what about our P2? We are given 750 millimeter mercury. So we are first of all identify what we are being given. Let us now write the formula. We now take from the formula P1 V1 is equal to what? P2 V2. What are we looking for? We are looking for V2, final volume. So first of all, make V2 subject of the formula. Make V2 subject of the formula. What do you mean by that? That means that our V2 will stand below, while the other one is on the other side. So what do? We don't need for this place. We want to make V2 subject of the formula. So that means that we divide this side by what? P2. We eliminate P2. So P2 will cancel out P2. Leaving out with our what? V2. V2 is equal to what? P1 V1 over P2. So that is it. So this is how to find V2. Now, put the data inside the expression. What is our P1? We are getting 770 multiplied by what is our V1? 375. What is our P2? Our P2 is what? 750. So everything in centimeter cube. So if you want to multiply our 770 multiplied by 375. When we multiply 770 times 375, you look at what is going to give us. So from that place, we are going to have from the expression, we are going to have 770 multiplied by 375. Let's do that one by one. We have 288,750 divided by 750. So when you divide it by one another by 750, what do we have? We have 385 centimeter cube. So I want to look at it very well. You observe that as the pressure decrease, volume will increase. So that means that in a summary, what Boyle is telling us that when the pressure increases, volume will decrease. If the volume decrease, pressure will increase. So this is what we are having today on the Boyle's law. So in the next class, we are going to be talking about Charles' law. At least from today, we are going to see a calculation on the Boyle's law. Now, so let us, before we end the program, I want you to kindly subscribe to my YouTube channel, Adeomilati. Press the button. When you subscribe, you are going to see other topics which I have done in chemistry. So till we meet again, I say remain chemically intelligent. Bye bye.